everyone. This is James from the CTRL+Listen Podcast, brought to you by Octopart. I am here with my co-host Inga Woods-Waight, and we have a guest for you today, Phil Salmony. I bet a lot of you already know who this person is. He's a very well-known engineer. He's behind Phil's lab. Thank you so much for coming on the show. Really great to have you.
Well, thank you very much for having me.
Anytime. Appreciate it. So just for anyone who isn't familiar with you or your work or Phil's lab, do you want to maybe tell people a little bit about yourself and what it is you do?
Sure. So predominantly I'm an electronics and PCB design consultant. Been doing that for quite a number of years. So self-employed, but have worked for a number of different companies throughout, mainly in aerospace and drones, and more recently, far more in the audio sector. So professional audio, mixed signal and electronics. And I guess where a few people know me from is my YouTube channel, Phil's Lab, which I started about 3 to 4 years ago, pretty much out of my own necessity. So just doing tutorials about electronics design, PCB design. And yeah, so I also offer courses and so do various tutorials weekly pretty much, and also create content for Altium, Octopart, and so forth.
Yeah, great content. We appreciate that. And there was just one that went up recently. If you want to see that, go on our YouTube channel. You can check that one out. Phil, do you want to tell us a little bit about your career and the path that led you to where you are as an engineer?
Yes. So electronics was pretty much always a thing for me. My dad is an engineer as well. Back in the day, he worked for IBM for 20 years, also designing electronics, first kind of computers with transistors. And so we also been doing electronics together, and then it's a fairly natural choice for university. And during university, in my second or third year, a friend showed me PCB Design, KiCad at the time, which is a free tool. And that got me completely hooked on PCB Design, even more so than I was on electronics beforehand. And this opened many, many doors for me, new opportunities you can do with PCB Design rather than just breadboarding and so on. So that was the first introduction during university already. After university, I worked for a subsidiary of Airbus for a short time before then moving on to an own startup as a co-founder in Denmark. And that startup basically created a flying laptop, so a drone which had an NVIDIA computer in it, which can do AI, machine learning, various peripherals and sensors, and I was responsible for the electronics there as well. That is now still existing in a different company. It's a French company now, which the drone is called Cobra. Anyone interested, they're currently releasing that, and the electronics still live on, which is quite nice. But after that engagement, I then went on to be completely self-employed as a consultant, electronics, and these days I work predominantly on pro audio systems because I'm a musician myself, and that ties in quite nicely.
What type of music?
Oh, it's an incredible mix. So for guitar, do you play as well, by any chance?
I don't play, but I'm heavily involved in the music scene. Okay,
very cool. So guitar-wise, it's mainly 80s rock and metal. I'm missing the hair, but other than that, that's the main thing, but it's quite a broad mix. But yeah, awesome. Anything with guitar.
I'm going to speak to you about that after the podcast.
I'm going to have to ask, was one of your first projects in PCB design something for your guitar, like a synthesizer or anything like that?
Definitely. And that was one of the first things with the microcontroller was, how do you make your own guitar pedal, like effects pedal? Because I'm a huge fan of DSP as well. And I don't know if I'm too lazy to creating analog circuits, but it's so cool that you can program guitar effects pedals in software. So that, yeah, exactly. That was one of my first projects.
Awesome. And like you said that you were introduced to PCB design and everything like that. How hard was it for you to be able to find, educational content like what you're doing now? Was it hard, and that's why you created Phil's Lab to make it more easily accessible?
And that's exactly right. So at the time, it felt to me there was YouTube content on engineering and electronics, which I'm very grateful for, helped me through university. But on PCB design at the time, 4 or 5 years ago, there wasn't particularly much, I'm sure you're aware. Yeah. And the first video I made for the YouTube channel was for me. I essentially looked at loads of data sheets and application notes. How do you do this? How do you use the specific ECAD tool? Compile that together. And that first video, I think it's still up, is that first video, which was for me at the time, so to speak. So yeah, that was luckily somehow started or filled a niche, at least in that educational sector. But now there's loads of content also from Altium. Altium Academy has been incredibly helpful also for me today and for many others from what I've seen.
Great to hear.
Did you get any guidance when you were doing your PCB designs or anything, like getting reviews over them, or how many failed attempts did you get in before getting a failed circuit board back and realizing, oh, I accidentally messed this up, or it was off by this much?
Yeah, I mean, starting out, there was, I don't think there was any smoke, but things certainly didn't work at times. Definitely to start out with. And also and there's so many things to PCB design if you haven't done it before. And I didn't have, other than my friend knowing how to maybe draw or trace on that tool, we didn't really know what we were doing. So just choosing package sizes, what's 0402, why does that exist in Imperial? So I think the first module I designed, I had these huge through-hole LEDs and 0201 resistors on it. So yeah, let's forget about those first PCBs, but it was a good learning experience. And I think that's how I learned quite a lot, was just making mistakes, iterating, looking at other people's designs. But other than in companies, there wasn't very much of a review process, unfortunately. And that's also one thing, being self-employed. Yes, you do work with companies that have their own engineers, but as a consultant, of course, you should hopefully be the one that knows maybe a bit more and helps with the PCB design process. So that is interesting, to say the least, but thankfully with a few years of experience, things have been going well for the most part.
Oh, that's great.
For someone who's coming out of school, who's trying to decide if they want to work for a company or be a consultant, what would you say to them? What's the perks of both?
Well, I think straight out of school, it's quite difficult to land a consulting or contracting gig for what I've seen. I may be a bit different on that end because the YouTube channel helped with promotion as well. So only a short while after university, I was able to start my own little business, so to speak. But straight out of school, I find it very difficult. So I occasionally browse forums and so on, and people getting advice or wanting advice on becoming a consultant, a contractor. And the general consensus is that you should spend, which I agree with, a number of years in a company, having formal review processes, seeing how to do things in practice. Not saying that you can't learn it on your own, but if also a requirement is, having a roof over your head and feeding yourself, Which no, but
you end up building bad practices too. It's hard
completely. Exactly, and also being exposed to more and more complicated projects, I find, just so you can improve your skills, is maybe more easily done in a structured framework such as a company. So that's what I would recommend: is gather some experience, have some mentors. It's great to have people to ask.
Awesome. I want to go a little bit more high level stuff here. During your time in the sector, what have you seen as some of the trends that are kind of have been developing over the years? Like, what's a current trend in this area that's really worth paying attention to?
With regards to PCB design, there's a few different things. So high-speed, first of all, I think modern PCB design should be comfortable with various high-speed interfaces, but also miniaturization I've seen a lot. So even, for example, guitar pedals or audio gear, you need to start being able to comfortable with smaller packages, knowing the assembly processes, what can go wrong, and so on. Maybe working with HDI, even though that, at least in my area, isn't particularly common. Miniaturization, mixed signal as well, being able to use RF, analog, digital on the same PCB or a combination of PCBs, I think is quite critical, at least from a design point of view. And also just connectivity, especially embedded systems, being able to add on RF transceivers, make sure they work fine with other systems on board. So again, this kind of mixed signal design, at least from my world, is what I've seen a lot more of. Now, I must admit, I'm not too at the forefront of PCB design or working on ultra HDI or very, very high layer count boards. So my missing out on, but from what I've seen, even in what used to be audio, 2-layer boards, 1-layer boards, now moving to fairly complex mixed signal designs and quite high bit depth, just being comfortable with those kind of design techniques. What I've seen, but.
Awesome.
Now, when you're talking about like mixed designs and everything, like when you're talking about, planning and working with these, is there any like key differences between, analog and digital circuit designs?
Yes, so there's definitely a number of things I always try to tell myself or to pay attention to with the mixed signal designs. You really have to be, with mixed signal, the main thing, to me at least, is separation between the analog digital domains, really sectioning off the power supplies, choosing the right power supplies for the analog digital sections, and so on. Whereas digital is, of course, fairly forgiving. And analog is its own thing as well. Depends, of course, on the frequency range and so on. But I work predominantly in audio, so mixed signal definitely has its challenges. But at least in the audio domain, once you've done it a couple of times, there's these repeating patterns that always come up and up again. Basically, just separation and having clear boundaries between analog and digital is what I found to be always work, basically.
Altium 365 lets you hold the fastest design reviews ever. Share your designs from anywhere and with anyone with a single click. It's easy. Leave a comment tagging your teammate and they'll instantly receive an email with a link to the design. Anyone you invite can open the design using a web browser. Using the browser interface, you're able to comment, mark up, cross-probe, inspect, and more. Comments are attached directly to the project, making them viewable within Altium Designer, as well as through the browser interface. Give it a try and get started with Altium 365 today.
What would you say are some of the things that most often get overlooked in engineering and design?
Most often overlooked in engineering and design. In what particular area is it?
Probably like in designing or like sending in for manufacturing, like maybe overlooking a layer, or probably putting too many components, over engineering it.
Yes, I mean there is definitely some over engineering to it. Overlooking, I think a lot of companies lack a formal design review process, or for example, when you're generating manufacturing data or doing the final steps of checking, there isn't really a process in a lot of, especially smaller companies I've seen. So in larger companies, there are quite often these processes in place, but in smaller companies, everyone either does their own thing or it's not organized in some sort, and that's a way you can catch a lot of mistakes, for example. Even just scanning through your Gerbers or whatever export format you're looking to gives you a completely different view on things. And just having a pre-arranged list, to me, is really useful. And yeah, but I do see that missing in quite a few companies I've worked with.
Do you feel like you have developed a good, how would you say, planning or perspective of like, okay, what to check, and have your own little checklist?
Yes, no, completely. I try to maintain my own checklist, and that's one video I'd love to do in the future, but I feel like that would be several hours long.
It's needed.
Yeah, definitely. But I don't know, what are your experiences with that? Do you have your own checklists, or have you worked with companies that...
I have my own little checklist, but like I still need to have like mentors to be able to tell me, okay, well, you need to look for this, you're missing that, or like, I'm like, oh, I didn't think about that. Like that, some things you get so used to doing that you kind of like miss it under a big overview when you're trying to get it out, and then you kind of miss it and then it comes back to bite you.
That's completely right.
I don't have one that's really set up, but that's why I love seeing everybody's different checklists and how they approach it, because that makes me think, okay, well, maybe I'm missing out on this, or like that's a really good idea on how to do that process.
Yes, that's completely right.
That's why I was kind of curious.
Yeah, no, definitely. And it's a shame that there isn't some sort of, community checklist. There are some on GitHub I've seen, or some blog posts, but they aren't particularly exhaustive. So maybe with this next or a future video, it would be cool to have a collaborative Git page or article where people can add in, and we can all create a global, so to speak,
open source of a checklist for PCB.
Yeah, I think that would be incredibly useful also for myself, because there are things on my checklist that probably I've missed, and then I might make a mistake and have to add it on later. So the more mistakes you can minimize, I'm all for that. Yeah.
That's that kind of raises a question for me. I want to ask: is there some sort of global standard with PCB design, like a minimum sort of quality level that should be maintained? Obviously, it's not enforced by anyone, but do you think there sort of is an expected level of quality?
I mean, that's an interesting question. I mean, in terms of standards, there's of course the IPC, which lays out certain guidelines, but they aren't particularly. It's more, well, from what I've seen, more about manufacturing. There are, of course, some routing guidelines or sizing vias and traces, how you should do thermal relieves, what the spoke widths will be. So there are those guidelines. But what I found, designers will either have their own. So if 30, 40 years of experience designer will maybe not agree with certain ones and have their own ones. So there's a bit of not a uniformity in that, at least of what I've seen. yeah, that's a bit unfortunate, but maybe there's something to do about that.
Yeah, I only thought of that because you were mentioning that you could potentially have sort of a checklist that everyone contributes to. So like, well, maybe there's some standard that could be developed with like a quality check before something goes to manufacturing. But like you said, it's
no, there are.
Oh, go ahead.
Sorry, there are from manufacturers. For example, AMD Xilinx. I've seen a lot of. They have their own checklist for their parts, for example. So you can go through an Excel spreadsheet and say, okay, have I placed the right amount of decoupling capacitors and things like that. But that, again, can be very design dependent as well. What type of decoupling capacitors you need, where you've placed them. So there are things which you can't, I guess, say with such a certainty. But yeah, there's some list that at least hints to what is needed would be great. But I wonder how many pages long that would be. But we'll see. Maybe that'll.
You'd also have to get people to agree.
Maybe we can put a community and put it into AI and ChatGPT and then kind of format one. Now, talking about the AI, do you think AI has any growing importance in the electronic design?
Oh my goodness, yeah, it's.
I know it's a hot topic right now.
Definitely. I would like to say no, but I assume it's going to be inevitable at some point. I mean, at the end of the day, PCB design is just an optimization problem, and schematics. I mean, how many times have we created the same schematics over and over again? It might be a different microcontroller or FPGA or something, but it's definitely not something that couldn't be automated, at least for the most part. Of course, there'll always have to be. Well, I think. People involved, but I definitely think at some point it's going to be automated. The question is the dimensionality of PCB design. It's quite complex. It's a very high order problem. How long will it take until AI machine learning is far? But I don't see it as an inevitability, unfortunately. So hopefully will have retired by then, but that's still another 30, 40 years.
Oh yeah. Yeah, because I know this with ChatGPT and everything. When you try to type in formulas or try to get answers for certain numbers, it gives you wrong calculation on or how to do coding and everything. If you know what to look for, you know that it will put it wrong or you have to know how to prompt it, and a lot of people don't know how to prompt it properly. So I think we have a good ways, and then it might be the same thing with auto routing. It's going to connect anything that's a circle to a trace line and everything. It's no, we're still good for that.
Yeah, completely. I sometimes go back, as you said, to ChatGPT, just type in something like maybe some snippet of code, and I just pray it's wrong, and usually it is. I don't know if I'm just creating the wrong prompt, but that makes me somewhat happy. Maybe I shouldn't be, but yeah. Same thing with auto routing as well. I tried at times, and Altium, of course, has got a fairly decent auto router in it. But yeah, I know. I just also like drawing traces and connecting dots. Maybe that's a different thing as well.
From what we've seen with people who've come on the podcast who work in the AI and design space, it seems to be a very similar thing across the board with that area, ChatGPT, all of it, where it's more used as a tool to save time than something that's actually used to create something of value. So it's not at a point yet, it would seem, where it can actually design a circuit from scratch, but maybe it can save you all the time drawing out the basis of it so you can actually get to the more complex part yourself. No,
definitely. And I'd be all for that. I don't want to have to place end decoupling capacitors for every power pin myself. It would be great if a tool could do that. I mean, and personally, I just love PCB design. If someone could do the schematic for me, which of course people do, but that would be great. And if an AI could automate that, at least the schematic part, that would be a really huge, huge time saver. Of course, as a consultant, when you charge by the hour, that might not be the best thing. But
just don't tell the client. No, okay.
I'm afraid I can't say that
now. I want to ask again about the engineering path. Do you have any advice for anyone looking to get into the engineering field who's considering maybe studying engineering?
So for me, it was basically just a given. My dad, I don't know if he forced me into it, but he pretended well enough that I liked it anyway. So that's always a great start if you're interested just because you have a hobby that somewhat aligns. For me, it was music or generally just building stuff. So that aligned quite well. I think just a natural instinct. I mean, there's so many aspects of engineering, just happen to be electronics. If you're genuinely curious about how things work, I think that's a great start. And for me, I don't think I would personally do a job that I'm not at least somewhat interested in. I think also there's great career prospects. I mean, engineers are needed in pretty much every different sector from what I've seen. And it's a hugely evolving and interesting field. And yeah, I don't think I get bored of that. And getting into it, my advice would be, I think, also start as soon as you're interested, finding a project that you want to design or develop, if it's mechanical, electrical, or whatever, but have tried, rather than just following school or university, create your own project. And I think for me, that also really helped during university, getting practical hands-on experience. For me, and what I've seen from a lot of other people, university is quite theoretical. Of course, there's differences. And I gained my most practical experiences by just accompanying that with my own project. And that was not because I want to get a higher starting salary or because I want to put that on a resume. It was because of pure interest. So if I would suggest pursuing personal projects.
Yeah. Do you still have like files from like your very beginning project, so you could be able to like remind yourself, oh, don't ever do this. Like the first PCB design is always the worst one. So you remember how far you've come to like now doing like, 42 layers or something like that.
Oh my goodness. Yeah. Unfortunately, at the time, I was quite proud of it, my first PCB. And my dad...
Aren't we all?
Yeah. My dad framed it, and I keep asking him to take it off the wall,
Oh, no.
but it hasn't happened yet. So maybe I have to send him this video as a final plea. But yeah, no, it's great to see. I mean, even looking back, I don't know how you feel about it. If you look back 6 months and you don't see, oh my goodness, what have I done the last PCB? Then that to me,
What was I thinking?
right? And that happens, and I'm glad in a way that happens, because then I think I'm improving. I'm making maybe complicated designs. I'm changing the way I maybe do things, design things, which to me is good. But then I always think, okay, what am I going to think again in 6 months or in a year time? What am I doing now? But to me, I think that's, I think most people have that. I'm not sure. I don't know how you feel about that, but
Oh no, you're not alone. Trust me.
good. Okay. No, but I think that's a sign of improvement. But yeah, I look back at my first PCB designs and think, oh my goodness. But then again, without mentoring or something, or having someone to look over your shoulder to tell you that's not right, the only way, I guess, is by learning about doing mistakes. And yeah.
Do you feel like having a portfolio also helps you, like, with all your designs, as a student, getting into the career, show, okay, well, this is what I'm capable of. This is how I problem solve this, design or schematic or everything like that. Do you think that's something that, students who want to get into the electronic field or like, electronics engineering field should probably start compiling or creating a GitHub with their files so people can be able to review it?
No, that's a completely great point. Yeah, exactly. That helped me the most during applications and job interviews. We didn't talk about any of their questions. We were discussing projects of mine or going through the PCB, and actually bringing something physical to the interview was one of the coolest things, because then you can just turn it around and talk about your
You
thing.
can just gush about it. Like, this is this.
Yeah, and it's great. And usually at least the companies I've interviewed for, they love it. And it's great to have someone also to talk with, and you just talk about the design choice and things like that. And it's great having somebody to show. Yeah, so that's a great point, definitely.
Would you say, is there any like, skill sets that, students should start like looking into, like developing? Like, should they start looking into like getting certifications if they can, or like, just doing little tutorials here and there, like the little online schools? Or do you just think like the portfolio, but what's something else good to have? Like, I know communication, being able to explain your design is one, and then having like, a good format of how to present stuff. What would be some skills that you have learned over time you think is beneficial to those entering into the field, or like going into corporate, different from, consulting?
No, completely. I mean, basically everything you said before. So predominantly having something to show. If it's maybe your first job or you're applying for jobs, because oftentimes the work I do or you do in companies, you can't publicly show. So it's always good to have side projects. If, of course, the time and if you can still be bothered after work is another question. No, I think it's communication, or being able to express your ideas, being able to talk about people, be able to handle and take feedback. I mean, there's times where I make mistakes, I'm wrong, and it's, of course, not particularly pleasant if you make mistakes, but learning from those, having feedback and being able to be accepting of constructive criticism, I think is a very good skill to have, and being able to communicate that with other people as well. And especially in company environments, or if you're planning on becoming a consultant, is negotiating, talking to people, and being communicative. So that's definitely a skill to have, rather than just drawing traces and adding capacitors onto schematics. Definitely.
So, speaking of skills, that raises another question. How important is fully understanding the design software that you use?
So I think it's quite important. It just allows you to do your job a lot more efficiently. Of course, there's going to be when I started, for example, with Altium or any other tool, there's quite a steep learning curve, but after 1 or 2 weeks or maybe a month, it becomes like any other tool in terms of usability. But yeah, just being able to know the little shortcuts, or how to re-pour polygons quickly rather than going through the menu system. It saves so many clicks and so much time. If you add that up of the time you're working or working on design, I would definitely suggest getting very familiar with your tool, and also with a variety of tools. If that is PCB design software, if it's simulation, if it's various different SPICE simulators, because different companies will use different tools, and you might see a sort of crossover between the tools, and then it's just a matter of learning different shortcuts. So, for the YouTube channel, I predominantly feature Altium, but I also try to teach tool-agnostic design. So creating or adding a capacitor in one tool is very similar to doing another tool. So while the tool is important, shouldn't be maybe the main focus.
Sure. No, definitely. Do you think it's kind of worth attending those like workshops and watching the tutorial videos and stuff for those tools to find those smaller features and shortcuts?
No, definitely. I actually also fairly recently did the Altium Advanced course, and that was useful as well because there's many shortcuts that now I finally use, where I just went through all these menu systems, or I didn't even know features that were available in Altium, for example, or whatever ECAD tool you use. There's so much stuff I hadn't maybe seen before that at least knowing about it, that you might use it in the future, is really good. So yeah, if it's free videos or if it's courses, I would definitely just suggest that, because I tend to stick to the commands I know, and then I just try to do it very manually. But it's good to occasionally, in my eyes, have that exposure. Definitely.
Fantastic. Inga, did you have any other engineering career questions left, or did you kind of ask everything that you wanted to?
I think I basically asked everything, but if anything, I'll just go on Phil's YouTube and write in the comments, "Hey, Phil, I have a question about this."
Oh my goodness. Okay, I'll keep my eyes open for that then.
Well, Phil, I think that's kind of everything we had for you. The last question is, if people want to check out your channel or follow you or learn from you, where are the best places to do that?
So the first place is YouTube. If you type in Phil's Lab, that should hopefully be one of the first few hits. So I typically release videos every 1 to 2 weeks, so 2 times or more a month. Altium Academy, I do have a few videos as well, and for Octopart, there's a new series, so spread across various bits of YouTube. I do have also courses, so if you know Robert Ferenek, I offer courses via his Fedival platform, so that's another way of getting more info there.
Oh, you just reminded me. I wanted to ask you, you were just at Embedded World. How was that?
Oh yeah, Embedded World was loads of fun. It was we spoke earlier briefly. It's the YouTube thing is great, and the comments are usually very lovely, but it's such a disconnect from, well, a slight disconnect, let's say, from the real world. So it was great to meet people in person that watch the channel, and also Robert's channel. It was great to the small amount of time I had to actually walk around, see what's there as well. So it was great. So hopefully you'll be there again next year.
Great. Yeah, our team that was there said they had an amazing time, and the amount of people that you just meet like on a daily basis was kind of mind-blowing, the connections that you make.
No, I was very happy to see Altium there as well. I believe last year I was there as well, and the Altium didn't have a stand or booth, so it was great that they were there this time.
For sure. Well, thank you so much for coming on the show, and we really appreciate you taking the time. It's been great chatting with you.
No, thank you very much for having me on.
Anytime. And for everyone listening at home, you can find the description and links for Phil's channel in the description below. And tune in next week. We'll have another guest for you.